Alright, here we are with the Physics 2021 WACE paper. I'll be doing this one and then the rest of my methods exams, or however many I get through over the next 2 days before my actual methods exam. It is the 1st of November right now. I just did the 2021 methods exam. So yeah, 3 hours. Let's just get started. Some energy levels N for hydrogen atoms are shown below. Electrons of 12 and 2 are incident on the hydrogen. Calculate the LNGs of all scattered electrons in electron volts. You can already write 12.2. So then E1 to 2 is equal to, so it would be 13.6 minus 3.4, 10.2. And I would say less than 12.2, therefore possible. And then, so then electron from 1 to 2 scattered will be 12.2 minus 10.2, which will be 2 electron volts, because it wants to scatter electrons. So that's just the difference in energy. And then 2 electron volts will be left over. It's on the hydrogen atoms. Energies of all scattered electrons in electron volts. I feel like there's going to be a lot, isn't there? So alright, 2.00. All scattered. Is that gonna be okay? 13.6 minus 1.51. It's 12.09. So then E1 to 3 is 13.6 minus 1.51, less than 12.2. But can I go from like 2 to 3? Because it doesn't say it's in the ground state. So wait, hold on. I have to put my timers on. I'll be back. Okay, I'm back. This is gonna take me forever. 12.09, sorry, 12.2 minus 12.09. It's gonna be 0.1 electron volts. 110, and then I can go 6 minus 0.85. So 13.6 minus 0.5 is too far. E1 to 4 is 13.6 minus 0.85, 12.75, and 12.2, that's not possible. But then I can go from N2 to all of them, N3 to all of them. No, they can't expect me to do all of that. Okay, I'm just gonna let's see, E2 to 3. E2 to 3 will be 3.4 minus 1.51. No, there's no way they expect me to do this. Yeah, no, okay, I'm not doing all of that. Because that's like what? That's over 10 things I would calculate. Yeah, no, I'm gonna say those 3 are it. Maybe if I come back and I'll do the rest. Okay, using information from the formula data book, calculate the mass of a bottom quark in kilograms. This is an easy thingamabobby. So mass is equal to, of a bottom quark, 4.18 GeV per c squared. E is equal to mc squared. Mass is equal to energy. Energy over c squared is 4.18 times 1.6 times 10 to the negative 19 into the 9. Plus c squared. Wait, I don't think I'm doing this right. Hold on. 5 by c squared. So the energy 4.18 GeV. So the mass is energy over c squared. 10 to the 9. 19 all over 9 times 10 to the power 16. So 7.43 times 10 to the negative 27 kilograms. That seems correct. .43 is 10 to the negative 27. Okay. DC motor is set up. Calculate the magnitude and give the direction of forces. Okay, hold on. I'm gonna have to get this up now. I'll be back. Back. Calculate the magnitude and give the direction of the force on AB and CD of the loop using the directions provided on the table below. I don't think I'm looking at the correct image actually, because I see nothing with numbers. Calculate the magnitude and give the direction. Oh wait, the numbers are here. Okay, current of is that. I'm not sure what one they're looking at though. Okay, so let's see the force. So force is equal to, this one is ILB, and it's going to be the same on both sides. So 3.5 times I times L 45 to a uniform. Wait, I don't have a length. What force am I going to use now? Let's say how long this is. I don't think it doesn't tell me how long the thing is. Uniform 1.52 millitesla. A, B, and C, D. Okay, I feel like I'm not able to do this question. Current carrying conductor. Yeah, I don't have the length of it. Okay, but I can. Okay, I think I'm just gonna get rid of this question because it even shows me which way the forces are gonna go. So, unless I'm just completely wrong, I am gonna cut out this question, I think. Well, we're gonna see when I mark, and I'll just continue. So yeah. Okay, a proton in a linear accelerator is given energy up to that. Use equations for mass energy equivalent. Calculate the speed in terms of c. Answer the 5 significant figures. A proton is given an energy E of the proton is 0.1. Given an energy, so this is E total. So E total teraelectronvolts, which is equal to times 1.6 times 10 to the negative 19. So 1.6 times 10, 78. Given an energy. Is that total energy or is that just kinetic energy? Whatever. Okay, so I'm gonna say that. 1, 2, 3, 4, 5, 6, 7, 8 joules, and then ET equal to EK plus E rest. So then EK, ET, sorry, no, but yes, ET minus E rest, which is 1.6 times 10 to the negative 8 minus MC squared wait, no, I don't need this equation. I need that this is MC squared over minus is given an energy. Oh my god. Yeah, okay, I think this is EK. So E total is 1.6 times 10 to the negative 8 plus mass of a proton, which is 1.67 times 10 to the negative. What is a proton's mass? So negative 27 times 9 times 10 to the 16. So it's just probably 1.6. What am I doing? it doesn't even. It's 10 power 6 is 3 times 10 to the power of 8, so this is times 10 to the power 16. So 1.645 times 10, 3, 4, 5, 6, 7, 8 joules. So then 1.615 times 10 to the negative 8 mc squared 1 minus v squared c squared. So then square root of 1 minus v squared c squared is 1.67 times 10 to the negative 27 times 9 times 10 to the 16 over 1.615 times 10 to the negative 8. So this is equal to I feel like I wasted so much time already. This is 9.306501 because I want to 565, so I'm going to go really accurate. 4 times 10 to the negative 3. So then v squared c squared is equal to 1 minus that 9.3065 154 times 10 to the negative 3 squared. I would square that, and I'll square this, and move that over. So v squared is equal to 9.30650,154 0.9991338 c squared. So then v is 0.99996 c. 1, 2, 3, 4, 6. Say two main differences between hadrons and leptons. Hadrons are made of hadrons don't they experience one of the forces that the other doesn't? I think it's the, is it the strong force? So it's the strong force. And then another difference is hadrons. I'll say hadrons are made of quarks. And then hadrons experience strong nuclear force. While leptons do not. Okay, so leptons are not. Well, leptons are fundamental. Fundamental. Wow, it's already been 20 minutes and I'm barely on, like, what is it, my third page? Yikes. Identify an example of a hadron from the list provided and write your choice. Hadron is a proton. meson, and then a lepton could be a muon. Okay, 6. Calculate the distance between A and C. Student is determining the slope of which concrete. Only a 15 kilogram beam, a ruler, a 5 kilogram mass with one smooth face and one rough face, and a stopwatch. She places the 10 meter long uniform beam on top of the sloping structure of 4 meters of the beam, hanging over the end of the structure shown below. Student places 5 kilogram mass with rough side at increasing distance until the beam starts to tip over. She places that mark at C. He wants the 5 minute slide on a smooth surface. She measures the time to reach C as 3.3 seconds. From the rest of A, meters theta. Places the 10 meter long beams on the sloping structure. How am I supposed to do this? Calculate this between A and C. It's 3.3 seconds. Calculate this between A and C. So mg sine of theta mg what? I do not get these questions. This is theta. This wrong. That's theta. G sine of theta. So then acceleration is equal to G sine of theta. I don't get this question at all. Calculate the distance between A and C. So T equals 3.3. Until the beam starts to tip over. Oh, so I need to take. Oh, it's a torque question, not a mechanics question. So from B, so take moments around B. Moments around B. Sum of the anti-clockwise will equal the clockwise. Anti-clockwise, we have the mass of the strut. So we have 15 kilograms. So 15 kg. So 15 times 9.8 times, and if it's going to be a meter away because it needs to be 5 meters on the inside. So this is 15 So 147 Newton meters. Sum of the clockwise will be 5. But it's actually going to be sine of theta, isn't it? Because this is 90 minus theta. Perpendicular distance. How do I do this? Go back like that. I also need something like that. Oh god, I can't think right now. Okay, let's work this through. So that's my horizontal. So that's my perpendicular to this. And then I also have some on the perpendicular to that. Must be theta. So this is all cosine of theta. It's 90. It's 90 minus theta, so then that must be theta. Okay. So it's mg cosine of theta equals mg to the x times so this is actually 1 cosine of theta, and then I assume it would be similar over there, so this would be can I just say both will have the cosine term, so I can just remove it. I don't know, 5 times 9.8 times x theta. It's theta. Ninety minus theta, that has to equal 90. So this is theta. 6 times 1 cosine of theta. 5 times 9.8 is 49 cosine of theta x. So then 49 theta x equals 147 on cosine of theta. So then x is equal to 147 divided by 49 is 3 meters. 3.00. So then the distance, that's 3 meters. Ignoring friction, calculate the angle of the slope measured from the horizontal. How am I going to do this? I don't understand how to do this. She measures the time to reach C as 3.3 seconds. Okay. So then E equals 0, S equals 9, T equals 3.3. Okay. So let's put this all together. So 9 is going to be equal to 0 plus half of A times 3.3 squared. So then A is going to be 9 times 2 divided by 3.3 squared. 1.653. And then A is equal to G sine of theta. So then theta is going to be inverse sine of 1.653 all over 9.8. So theta is 9.71 degrees. I feel like did I spend 10 minutes on that? Jesus. A bobo dough as shown below can never be tipped over. Even if its head is held on the ground, it will stand back up when released. Explain how this is possible. Now I have to get this out. A bobo head. Okay, I'm gonna pause timer while I bring it up, but it shouldn't take too long. Let's see. Bobo head. Okay, got the picture up. His head is held to the ground. You must include in your answer the relevant conditions required for static equilibrium. Use the diagram on the right to illustrate your answer. Okay, so then for static equilibrium, the sum of forces and torque must equal 0. And then also, whenever the bobo doll is is tilted, there is a torque experienced at the point of contact with the ground. That one's the correct. Then what's the pull the doll back upright? I don't think my explanation is very good. Center of mass is above. Then thus as the doll will always rotate in the direction of torque. Or I should say supplied by its own weight. And stand upright. That's probably a terrible explanation, but we've got to get moving. Complete the following table for an antiproton. An antiproton will be proton negative, or no, you can do a bar on top. So then up, up, down would be down, down, up. Oh wait, no, I can just do up, up, down, the bar on top. So anti-up, anti-up, anti-down. Electric charge will be -1, but the mass will be the same. Okay. But there's so many of these that I can't see. Oh my lord. Space station. Oh, let's bring this one up. Question 9. Where is it? Question Let's see. Shaped like a hollow donut that is rotating uniformly out of race. What is the period rotation of the station? Experiences the inside the same weight force you would experience on Earth. Outer radius is 460. The same weight force you would experience on Earth. So then force of normal equals force of G. So normal will then equal mg. So but then mv squared over r is equal to this normal force. Because it would be the resultant centripetal force will match the normal force. Okay, so V squared of GR, so 9.8 times GR, but also V equals 2 pi r on t. So then 2 pi r on t must equal square root of gr. So then t must equal 2 pi r square root of gr. Should be 2 pi times 460 square root of 460 times 9.8. 43.0 seconds. Ooh. Not sure if I like that answer. Normal force. And that's the only thing keeping her. Okay. Then a very strong 55-gram neodymium magnet is dropped vertically down a hollow copper pipe. Eddy currents induced provide an upwards force which enables the magnet to reach a terminal velocity of that. Calculate the power supplied as heat to the pipe as the magnet falls at this velocity. Power. So then, second power is equal to, what's the actual power formula? Work is the change power equals work or change in energy per second, and then delta E, so and then we can say that delta E in 1 second is just going to be the change in gravitational energy, so it's equal to 9.8 times mass, which is 0.055 times height, and we move 8.5 centimeters, so 851. So this is 0.0459 joules. So then the power is 0.0459 all over 1, so 0.0459 watts. So 4.59 times 10 to the negative 2. Silver has a higher electrical conductivity than copper. How would you answer the part A change? On silver, it was part A, it would be traveling slower, so it would decrease. Okay, question 11. High-speed charged particles have many technological and scientific applications. One way of accelerating these particles to high speeds is by using strong electric fields. Through what potential difference would a proton at rest need to be accelerated for it to reach a speed over that? Proton at rest for it to be accelerated to a speed. So delta E is equal to half of 1.67 times 10 to the negative 27 times v squared, so 6 times 10 to the power 5 squared. Times 10 to the power 5 squared. So I need 3.006 times 10 to the 16 joules. And E equals work equals QV. So then V equals W on Q. 3.006 times 10 to the negative 16 all over 1.6. 10 to the negative 19. It gives me 1.88 times 10 to the 3 volts. Okay, what would the final velocity of an electron accelerated from rest across the same potential difference? Accelerated from rest. So then delta E is equal to the same 3.006, that is an ugly 3, times 10 to the negative 16 joules. So then 3.006 times 10 to the negative 16 is half of its mass, not 19, sorry, 31. It's v squared, so then v is equal to, this is going to be square root of 2 times 3.006 times 10 to the negative 16, all over 9.11 times 10 to the negative 31. And this is all equal to 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. Ooh, we're getting very close to the speed of light. Jesus. 2.57 times 10 power of 7 meters per second. And what is the ratio of the kinetic energies once they cross with the same potential difference? Kinetic energies, they'll be the same. Just be 1. EK is the same. Therefore, 1 to 1. Because the potential difference, they both have the same charge and they both have the same voltage going through them. So, yeah. Okay. Cosmic microwave background radiation was first observed in 1947 by Arno Pezias and Robert Wilson at the Bell Telephone Laboratories on Murray Hill, New Jersey. They had built a decay radiometer that intended to use for radio astronomy. They detected to see an air division of Hunter. Briefly explain the origin of cosmic microwave background radiation as part of the Big Bang Theory. So the CMPB is the leftover radiation that has been spreading ever since the Big Bang. The universe ever since the Big Bang. and then we will say it started initially as gamma rays, I think. Yeah, initially as gamma rays, but has been cosmologically redshift. Initially released as gamma rays, but have been cosmologically redshifted and expanded. Cosmologically redshifted and had its lambda lengthened due to the expansion of the universe. Okay, how does the study assume to provide evidence the universe is expanding? Study of CMP provide evidence the universe is expanding. How does it provide evidence the universe is expanding? It can be detected everywhere, so maybe I'll say because it can be detected everywhere. It can be detected everywhere. Signifying, or hence signaling. Oh, there's a word I'm trying to think of it. Hence, proposing the idea, strongly supporting the idea that the universe was once contained in one tiny singularity before rapidly expanding. Before rapidly expanding. I think that's it. Can be detected everywhere. There was once a tiny singularity before rapidly expanding. I think so. Cosmic microwave background. Okay. Okay, estimate the threshold frequency of potassium from the graph below. What is that, like 0.25? 0.25 by 4, 0.5. Say 0.4, 0.3, 0.35. But that's 0.25, and that's about halfway, so I say 0.38. 38 times 10 to the power of 15. Which will be, okay, let's sort this out a bit. 3.8 times 10 to the power 16. Or 10 to the power 14, sorry. So then each metal has work, describes the minimum amount of energy, estimate the work function from the graph below. Oh yeah, I should say x-intercept value, and then here I'll say y-int value. So the work function of potassium minimum, probably about -2. So 2.00 And these are just estimates, so 2 sig figs. Use your value, estimate the maximum velocity of a liberated electron if light with frequency shines on that. Shines on a potassium metal plate. So then E equals, so value from part B, so you want me to use that one. So then E of the photon is HF. So 6.63 times 10 to the negative 34 times 1.2 times 10 to the 15. So this is 7.956 times 10 to the negative 19 joules. Then I need to divide by 1.6 and then by 10 to the negative 19. So 4.9725 electron volts. So then EK of the electron is equal to EPH minus work function. So 4.9725 minus 3, or minus 2, sorry. So that's obviously 2.9725 electron volts. And I want me to find the maximum velocity. Which is then 1.6. I should just kept it all in joules. 4.756 times 10 to the negative 19 joules. If E equals half of mv squared, then V is equal to square root of 2 EK over m, which is equal to 2 times 4.756 times 10 to the negative 19 over 9.11 times 10 to the negative 31. 2 times 4.756. So 1, 2, 3, 4, 5, 6. So 1.02 times 10. Okay, give my answer to 2 sig figs. So nice. Good thing I checked that because I'm pretty sure it said estimate. 6 meters per second. The diagram below shows how the kinetic energy of a liberated electron is measured. Ammeter measures the photocurrent, and the battery can reserve and vary the potential difference between the metal plate and the detector. The potential is increased until the ammeter reads 0. Below is a graph of photocurrent versus the potential difference. On the graph, draw the same resulting curve when light of the same frequency but lower power is shown on the same metal. So the photocurrent will be 0, so it's going to be lower overall, but it'll reach the same potential difference because they're going to have the same amount of maximum energy. Something like that, because all the photocurrent does like the same frequency but low power. So lower power means that we're gonna have less overall incident electrons. So that means that my photocurrent, because there's less electrons moving through the circuit, my current overall is going to be lower. However, since they're at the same frequency, they need to start at the same potential difference and end at the same potential differences. I think so. That looks correct to me. Reaches C at the same point. What happens when potential difference is higher? Yeah, I think this makes sense. Okay, at 0.2 kilograms, metal sphere of net charge of that is suspended by almost massless string in a uniform electric field. Place of the field like that. And the potential difference between the total and negative plate is that. calculate the strength of the magnetic field. So E is equal to voltage over distance. So this is, what's volts per meter, so 180. Distance is 1.2. 6 on 5, divided by 6 on 5, 30, 150? Yep, 150, 1.50 times 10 to the power of 2 volt meters, or volt per meter. 1.5. Calculate the tension in the string. So F net is 0. And which is equal to, let's say, the force of tension minus the force of the electric. So then force of tension is equal to the electric force, which is simply going to be F equals Q V over D, Q V over D. Oh, wait a minute, I'm clicking, because right here we know that work equals QV, right? We also know that work is equal to force times distance. But if my force is QV over D, and I times that by D, these cancel. Oh, no wonder. Oh, I'm learning. Okay, I see. Q is 2.7. How do you feel? 2.72? Yeah, 2.72. Times 10 to negative 6, because it's weight, it's milli. Never mind, so times 10 to the negative 3 times voltage over D. So then it is times 150. 2.72. Really, I can just write this as QE. So then 2.72 times 10 to the negative 3 times 150 is 0.408 newtons. I believe that's correct. Because the electric force would be negative charge. Wait, no. It's going up. Oh, okay. So that force is down. So it's actually force of tension plus the electric force minus force of gravity. Sorry, because since it's electric, it's negative. It's actually the force of electric is actually going to be going upwards because it wants to go to the positive plate. So force of tension is equal to F of G minus F of E. So this would be 9.8 times 0.2 minus 2.72 times 10 to the negative 3 times 150 minus 2.72. See, if I remembered, I could just put the number back in. But I don't. 1.522. So it's just 1.55 newtons. Nice. Yeah, because it wants to be going down, and then the electric force is pulling it up, and the tension is also pulling it up. Oh, very interesting question. Okay, the sphere is pulled to one side and released at the bottom. The sphere is traveling at 2.8 meters per second. Draw a free-body diagram of the forces acting on the sphere in this position. Label all forces. Do not show net force acting on the sphere. So we have some F of G at the bottom of the swing. The sphere is traveling at 2.8 meters per second. And then does it need to be even at this point? Three marks. There's probably 1 mark for all of them, 1 mark for direction, and 1 mark for centripetal. Sphere is traveling at 2.8 meters per second. Does it need to be equal height? Probably not. Imagine the tension is probably a little bit higher than the force of gravity. Obviously the force of gravity can't be higher. Yeah, okay, no, force of tension has to be higher because we need to be traveling circularly. If we're traveling circularly, we need my net force to be going upwards. So, yeah, I'll draw a bit more noticeable f of t. Maybe from here I'll draw it like this. There you go. Derive an expression for the net force acting in terms of the forces in your diagram. So net force is f of t minus f of g. Calculate the tension of the string at the bottom of its swing. So at the bottom of the swing, the sphere is traveling at 2.8 meters per second. Tension in the string. So then f of tension is f net plus f of g. It's going to be mv squared over r plus mg. So it's going to be 0.2 times 2.8 squared .81. Oh wait, no, it's gonna have an electric force as well, isn't it? So I'm gonna draw that as f of t. And there's another one where it's like f of e. Something like that. So it's tension plus force of the electric minus f of g. Tension in the string at the bottom of its swing. F of t is that f net plus f g minus f of e. Then minus QE 0.8 plus 0.2 times 9.8 minus 2.72 times 10 to the negative 3 times 150. I think I'm on the right track. Wait, minus f of e? Minus f of e plus f of g. Minus f of e plus f of g. Yeah, okay. Negative 3 times 150. 3.512 newtons to 3.51. gymnast performs her dismount from a 1.25 high beam. She leaves the beam with velocity at an angle of 55 meters on horizon. So UH launch velocity. Oh, they use V. Okay. So we'll go V vertical is 3.1. Sine of 55. So 2.54. And then velocity horizontal is 3.1 cosine of 55. So 1.78 meters per second, right? So 2.54 and then 1.78. Okay, calculate the time it takes for her to reach the ground, assuming she is vertical. Impact, what does that even mean? Oh, okay, that her feet land essentially. Okay. Reach the ground, so then S time to 0 time to 1.25 meters above ground. Actually no, S will be equal to negative 1.25 meters. Negative 1.25 is going to be equal to 2.54. Oh, excuse me. 2.54 t minus 4.9 t squared. So then 4.9 t squared minus 2.54 t minus 1.25 equal to 0. So then t is going to be 2.54 plus or minus square root of 2.54 squared minus 4ac all over 2a. So this is 2.54 plus square root of 2.54 squared minus will be plus 4 times 4.9 times 1.25 and 9.8. So 0.827 or negative 0.309. Clearly t must be greater than or equal to 0. Therefore t equals 0.827 seconds. So 0.827. Yes. Calculate her range R. Oh my god, I have to find what they're talking about now. So what is this? This is question 15. Okay. I assume it's just the distance that she travels. Horizontally. Page not found. Yeah, I have to try that. Yeah, cause wait. Still no. The PDF. Okay, if R is not the vertical component, then I will not be taking this question. So we'll say R equals S, and then S is equal to UT. So it's 1.78 times 0.827 equal to 1.47 meters. 1.47. So then calculate the gymnast's kinetic energy at the top of her flight. kinetic energy at top. So EK is equal to E mechanical, which is equal to 2 how much does she weigh? 42.5. So half of 42.5, and velocity is 3.1 squared plus 1.25 times 9.8 times 42.5. 1.25, 9.8, 42.5. So she has 725 joules of kinetic energy at the very top. And oh wait, no, at top basically EM. That's at the bottom. Sorry. This would be K. Plus EH or EP, I guess, equal all of this. So then EK is equal to that minus 1.25. Wait, so I have to find how high she jumps up. Wait, is range R at the top? Is it the top of her thingamabobby? Wait. Okay. Kinetic energy at the top of a flight. Otherwise, this wouldn't make sense. Okay, I think R must be the maximum height. Okay. See, I don't have. I can't see it though. Pilot beams. It says page not found. Okay. I'm gonna do a little bit of a cheat, and I'm gonna find out what R is from the marking key. I swear I'm not gonna look at anything else. So I'll go straight to question 15C and see what it is. So I'll be back. And then, okay, so what I'll do is I will look at what it is, but then I won't count this question here, R, towards the marks. Because I feel like we need R to find D. So yeah. Back. Was this? It was 1.47. So now I'm thinking, how are they expecting me to get the kinetic energy at the top of a flight? So the top of a flight. Wait. Kinetic energy. Half of mv squared. Is it that at the top I don't have any downwards velocity? I only have a cross. So then my velocity is only the horizontal one. So it's not mechanical energy question. It is only 2 marks, so mechanical energy for 2 marks, maybe not. Not without making it really weird and confusing. 2 marks. I think that might be what they want. I like how as soon as I drew the dot and I was about to draw like where my forces are, my velocities are, I was like, wait, I'm only going across because at the top my vertical velocity is 0. So I only have to worry about my horizontal one. So half of 42.5 and 1.78 squared. So 67.3 joules. Okay. Light does not travel at the same speed in all materials. When traveling from air to a different, light slows down and refracts. The amount of refraction is determined by the refractive index. It's calculated by the following, where V is the speed of light and C is the speed of light in the vacuum. Between 2 mediums, N1 less than N2. So if N1 is less than N2, then velocity 1 is greater than velocity 2. So light travels faster. Who was trying to determine the guys are measuring the refractive light index. Below the schematic of the experiment showing the angle of incidence and angle of reflection. Okay, they varied the angle and found that white light produced a rainbow effect, which made measuring R very difficult. So they changed the light to monochromatic red laser to obtain the results below. Okay, so turn the sine to 3 sigfigs. So 0.574 and 0.574. Sine of 23 is 0.971. Sine of 40, 643. Sine of 25 is 0.423. Sine of 45 is square root of 2 and 2. Our good friend, 0.707. Sine of 28 is 0.469. Sine of 50 is 0.766. Sine of 31, 0.515. Sine of 55 is 0.819. Sine of 33 is 0.545. Short. Okay. Oh, nice. I already did all of this. Look at that. Anyway, I want to think about this for a second. If N1 is less than N2 equals to the N, then velocity 1 has to be greater. Oh, well, yeah, because we're entering, what do you call it? We're entering a lower velocity, so then the angle lowers. That's how I was remembering. Yeah, okay. Never mind. I'm okay, guys. So sine of I versus sine of R. So if R is 0.39, then sine of I is 0.574. So each of these is 0.05, and there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. 0.05. And this is 9, 1. So 9, 1, and then 7, 4. So 6, 7, 4. Come on now. There we go. And then 423. 423 643. 423 623. Oh, I lost it. 423 643. 423 643. 643. What about there? 469. So I'll take 47 and 707. 247 0.707. It's about there. 515 766. 515 766. And then 545, and I've got 820. So 545 820. So one to the left of this, and then 4 up. There, and then include a line of best fit. Okay, did I do this correct? I feel like this point is a bit odd. 574 56 674. Yeah, I don't know. Don't think I can get much better than that. So line of best fit. Go 1. We pretty much hit these ones in the middle. Maybe a little off these. And that's a decent line of best fit. So about being like that. And the curve above. A bit flatter maybe. Something like that. Let's bring it up a little bit more so I can actually get these values. That's pretty good, I think. Alright. And as 1, use your line of best fit, determine the refractive index of the prism. Indicate clearly which 2 points are line of best fit. Give your answer to 2 significant figures. So let's go with this point. This is a very nice point. That is 0.34 and 0.6 to all the way up here. There's a very nice point here too as well. That is 0.55 and 0.815. Okay, so then M is equal to, wait, let me write my points down first. So 3, 4 to 6. To 5, 5, 8, 1, 5. So then M is going to be equal to 0.815 minus 0.6, 0.55 minus 0.4. So I get that M is 1.0238. And since M is equal to sine of I over sine R, sine R, M is equal to here, so sine of I, if I divide that by sine R, then this is N2 over N1. So M is equal to N2. So I do N1 sine of I equals N2 sine of R. And then I'll just bring this up here a little bit. So then sine of I over sine of r, n2, n1. Then m is equal to n2 over n1. So then n2 is equal to 1 times 1.0238. Wait, that doesn't seem right. Term the refractive index of the prism. So let's see, 815 and 0.55. Oh, this is 0.34, 0.39. There's my mistake. 39, so 1.3. 344 and 2 over n1, so 1.344. So then n2 is going to equal 1.3. Let me write this in 3. I swear I have like OCD, but for just the number 3. Okay. There are two phenomena described in this equation that support the wave behavior of light. List them below. One is refraction. And then the other is the other one. Refracting. Refracting. What's the other phenomenon described in this question that support the wave behavior of light? Oh, is it the monochromatic? The rainbow effect. Monochromatism. White light is consisting of all the rainbows. Maybe I'll say that white light consists of multiple constituent colors of light. Wavelengths of light. Okay. Speed of light. I'm not sure what else it could be. Okay. Let's see, how many until section 3? 28. Okay. The tolerance for all angles was plus or minus 1. How much does the percentage error change as the angle measure increases? as the angle measured increases, what? So let's say for lowest angle, as the angle measured increases, for 35 degrees, on 35 times 100 equals 2.857% for every, because it's every 5, okay. So this would be for every, so angle measurement increases by 5. By 5 degrees, therefore 1 on 5 times 100 equals delta percentage change, or delta percent error. So then delta percent error is equal to 20% error as the angle measured increases. Divided by 35 times 100 is 2. 40 is 2.5. 2.2. 2.18. How does the percentage error change as the angle measured increases? Okay, there's not an exact answer. Therefore, 1 on degrees times 100 will decrease as angle increases. Now, I guess say, for example, 35 degrees, 1 times 100 on 35 equals, oh my god, 2.85, so 2.86%. But then for 40 degrees, it's 1 times 100 on 40. So it's just 2.50%. Is that what we want? I don't know, man. Some of these are just so confusing. Okay, using the following trigonometric identity, calculate the percentage error of the sine of an angle incident of 50 degrees. Percentage error of the sine of an angle of incidence of 50 degrees. Then 50 plus or minus 1 degrees. So sine of 50, let's say 51, equals sine of 50 cosine of 1 plus cosine of 50 sine of 1. Plus cosine of 50 sine of 1. So this is 0.777 f of, if I get this for minus 7, 7, instead of b, so I get minus sine of 50, 766, 0.11. Okay, so it's the same. So then percentage error is equal to 7 all over 0.766 times 100 minus 1, or maybe minus 1 times 100, minus 1 times 100, 777 divided 0.766 minus 1 times 100, so it's 1.44%. You could have done 49 as well, and it would give you the same error. It would just be the other way. You would have to take 1 minus it, because it would be 1.44%. I think, let's see, sine of 50 cosine of 1 minus cosine of 50 sine of 1 gives you 0.755, which is again 0.11 away, just the other way around. The percentage error is 1.44%. 77. Nice answer. 766 times 100. 4%. Oh, I think, did I do something weird? 777 1. Yeah, put 1 and see what happens. 1 divided 0.7766 minus 1 times 100, 1.45. 0.45%. Wait, I don't need a percentage sign there. Okay, 22. Aeroplanes are designed to produce an upright thrust that counters their weight force. This allows them to maintain altitude. Magnitude of this upright thrust is directly proportional to the forward speed of the aircraft. It always acts perpendicularly to the wings when changing direction. The airplane banks in a circular path. A free body diagram is shown below. Draw a vector diagram showing how the weight force and the upright produce a resultant centripetal force. Label the resultant force. Include angle theta as shown in the free body diagram. Okay, easy peasy. Let's say that is R, and then this is mg, and this is theta. Because if this is theta, I can make a 90 triangle. Oh no, I don't even need that. I can just say that these are, this is a bisector of parallel lines. So these are both to the horizontal, I mean to the vertical. So then they have to be equal actually. And then here my F net. So the resultant force, or F of C, is the same. And then 90 degrees there. Just show horizontally to the left. Calculate the centripetal force on a banking an angle of 15 degrees to the vertical while maintaining constant altitude. So then it will be FC is equal to cosine mg over cosine of theta, because cosine of theta equals mg, well no, tan of theta. Oh wait, hold on, let me get this right. Tan of theta equals opposite over adjacent. So for fg, I just have to times it. Tan of theta equals fcmg, so it's equal to mg tan of theta. Then this is 5.6 times 10 to the 3 times 9.8 times tangent of 15 times 10 to the 3 F(t) is 1.47 times 10, so 4 newtons. The airplane is traveling. I think I'm going to finish these questions off and then leave the rest for tomorrow or later on today. If the airplane is traveling at that, calculate the radius of the circular path it takes while banking or maintaining constant altitude. Calculate the radius of the circular path. Okay, so 450 kilometers per hour equal to 450,000 meters divided by that to get minutes, and then seconds is 125 meters per second. So then we know that 1.47 times 10 to the power 4 is my centripetal force, but then Fc is also equal to mv squared over r. So then 1.47 times 10 to the power 4 is equal to mv squared over r. So then r is equal to 5.6 times 10 to the power 3 times 125 squared all over 1.47 times 10 to the power 4. 3 times 125 squared, 1.47 10 to the power 4. Okay, my radius is 5.95 times 10 to the 3 meters. Come on. With reference to vector diagram, explain why airplanes need to increase their speed to maintain altitude when banking. So then as explain why airplanes need to increase their speed when banking, part of the, did they call it the lift force or just the reaction force? The upwards thrust part of the magnitude of, okay wait, hold on, I'll say this. When maintaining constant altitude, F vertical is 0, therefore reaction equals F of G, and then when banking, some proportion or some portion becomes horizontal, becomes a horizontal component, action of vertical as RV, or say as R is all vertical, becomes a horizontal component, therefore RV be less than R, thus RV be less than F of G, however require do I add RV here? Yeah, okay. Require RV equals F of G. So then to increase RV, we must increase r itself as r is proportional to velocity. I think it said proportional to the forward speed of the aircraft. To increase r, v must increase. Okay, and then that's the start of the next. So I'm gonna leave it here for now, and then we'll come back later. See ya. Welcome back, everyone. We're gonna continue on. We got, I think we had an hour 17 and 03 when we left. So play that. Let's go. Two neutrally charged subatomic particles, each with mass m, are fired directly toward each other. Both have a speed of 0.6 c, as seen by observer O, shown in figure 1. The particles collide and become one particle c, which O observes to be stationary. No energy is lost due to interaction with the environment, and no other particles, for example photons, are emitted. Using conservation of relativistic energy, calculate the mass of the combined particles mc, giving it as in terms of m, the mass of each of the original particles. Then ET for one particle is going to be, actually no, we can just do it like this. ET equals 2 times we're going to do mc squared over 1 minus 0.6 squared times and then what's the mass? Is it plus? It's plus, so plus mc squared. ek plus e rest, so plus mc squared. And this is 2 times 1 squared 1 minus 0.6 squared plus 1, 4.5 mc squared. All I did was that I pulled these mc squareds out here, and then I just found what this would be and put those as 1. Okay, now find the mass of the combined particle m. So then if 4.5 mc squared equals its own mass 1 minus v squared over c squared, where v is 0. Therefore 4.5 mc squared equals mc squared over square root of 1. Oh wait, no, I don't think. Wait. It's going to be just equals mc squared because there's no kinetic energy. I think that's where we're going with this. And then what's this here? No, wait a minute. Calculate the mass of the combined particle mc in terms of m, the mass of each of the original particles. Mass of the new particle Open 5 equals mc squared square root of 1 minus v squared c squared. Combined particle mc. Oh, because mc would be its own thing, right? mc c squared v equals 0. Over 1. And mc is equal to 4.5 of m. I think that's what they want, because you can't just divide this MC and that M, because they're not the same variable, they're different. Okay, I think that's pretty good. M squared divided by C squared. Yeah. So 4.50 M. Explain why the velocity of the combined particles has to be 0 meters per second to conserve momentum before collision sum of momentum is 0 as equal mass and velocity but opposite direction. Opposite direction. Thus after collisions, sum of momentum or momentum of new particle must also be 0. And I'll say P equals mv. Clearly m cannot equal 0, therefore v equals 0. Okay, consider the same collision viewed by an observer x moving with velocity same maintains this velocity after the collision. Using formulas of relativistic momentum, determine the momentum of the system before the collision as determined by x. Express your answer as an m and c, the speed of light. Determine the momentum of the system before the collision as determined by x. So A terms of x, we know that this is going to be velocity addition, or that one, the velocity subtraction, sorry. This is going to be u minus v, 1 minus u v c squared. So in x's frame of reference, this is going to be 0.6 c minus negative 0.6 c over 1 minus 0.6 negative 0.6. x1 plus 0.6 times 0.6, so this is going to be 0.8824 c. And then relativistic momentum, so B is stationary in x's frame of reference, therefore P equals 0. Momentum of B equals 0, but then P of A is equal to mv squared, sorry, not just mv, 1 minus v squared c squared. So this is going to be equal to mass, which is just m, so m times 0.8824 c square root of 1 minus 0.8824 squared. So then 0.8824 square root of 1 minus 0.8824, 1.88 C. So 1.88. These calculations show that the answer in part C is the same as the momentum of the system after the collision as determined by x. Okay, so momentum of the system after collision say that u equals 0. But this is equal, it's still going to be negative 0.6 c. Therefore, equal to, v is equal to mu minus that 2c all over 1 minus 0 times negative 0.6, so that's just going to be 0.6c. 0.6 represents 0.6 squared. Oh, because my mass is bigger now. Stationary in X's frame of reference. PV. Just see A coming towards you really fast. Equals 0. So then P equal to MV, so 4.5C times 0.6C is MC. MC like this, 6 times 0.6 square root of 1 minus 0.6 squared. I definitely did a step here wrong somewhere. So like 3.38. Zero point 0.6 plus 0.61 plus 0.6 times 0.6, 24 C 0.824 square 1 minus 0.8824 squared. 88 MC. Did I get the mass here wrong? So combine pi equal MC squared. Okay, let's erase C squared. 2 times 1 over square root of 1 minus 0.6 squared plus 1. 4.5 C squared. No, that's fine. 3/8 after the collision determined by X. X times 1.
I'm a bit stuck, guys. Not exactly sure why. What's wrong? So after the collision, X is moving negative 0.6 c, and then this is stationary of 0. Is this mass here wrong? If that's just 2.5, okay. So MC, oh yeah, because that's just ET. Oh, what am I doing? This isn't EK, that's ET already. So I can't have ET equals ET. Okay, so that's 2.5. My bad, guys. That took me a while to figure out. Jesus. So this would be 2.5. 2.5 and 2.5 m. So here's 2.50. This is double of the total. That's, yeah. Okay, I don't know what I was writing over there. Because then there'll be ET equals ET plus E rest. That doesn't make sense. So this will be 2.5. And then this is equal to 1.88 MC, which is the same, equals P in C. So 1.88. Okay, there we go. Question 19. A group of students wanted to calculate the strength of the Earth's magnetic field in Perth. They set up a DC circuit with a selection of wire placed 50 millimeters above a compass. No current flowing. Line up with the Earth's magnetic field as shown in figure 1. Okay. When they closed the switch, they saw the needle deflect an angle of 80 degrees to the wire as shown in figure 2. It was pointed in the direction of the net magnetic field. The reading on the ammeter at this time was 3.8. Calculate the strength of the wire's magnetic field felt by the compass in this position, described in figure 2. This would just be F equals let me get out the proper one. I said ILB, I think. Wait. Strength of the wire is magnetic. So this is B equals UO over 2 pi times IR. And this is 2 times 10 to the negative 7, because UO is like 4 pi times 10 to the negative 7, I think. Yep. Times 3.7 all over 50 times 10 to the negative 3. So that equals 1.48 times 10 to the negative 5 Tesla. Okay, calculate the strength of the horizontal component of the Earth's magnetic field. So this would be going straight down, and then we have a little bit to the left. 80 degrees to the wire as shown. Like 80 degrees to the wire. So it's like that. Wait, no. How do they want me to draw my triangle here? If that's the 80 degrees, and that's 80. I think that's how they want me to draw my triangle. So let's do that. So we'll go. There's something. Bada bing. And bada boom. And that's 80 degrees to the wire. If that's 80, this is 80. Okay, and then the horizontal component of the Earth's magnetic field. Well, I know that this is 1.48 times 10 to the negative 5. So then this is B of E. It's going to be, so tan 80. Maybe the opposite, so BE over adjacent. And the Earth's magnetic field going to be equal to 1.48 times 10 to the negative 5, 10 of 80. So this is 8.39 times 10 to the negative 5 Tesla. 8.39 times 10 to the negative 5. That makes sense. That's 80, and this, if I drew it the other way, this would be 10. And going, oh wait, no. This would be, this here is 1.48 times 10 to the negative 5, and then this is B. Oopsies. So it's actually not this. It is 1.48 times 10 negative 5 B, 10 of 80. So this is equal to, I think 10 of 80 is greater than 1, so just give me a smaller number. 2.61 times 10 to the negative 6 Tesla. Nice. Tan 10 equals E over that. So if I do, let's see if I, this, yeah, it's the same. Alright. So 2.61 times 10 to the negative 6. The Earth's magnetic field at an angle of 66 degrees towards Perth, this is called the angle of dip. Use this to calculate the overall strength of the Earth's magnetic field in Perth. Okay. I have to bring this up now. Let's see. See if I can find it fast. Diagram of the angle of the dip. Come on, load faster. I'm gonna pause my timer while this loads. Wow, Could this thing take any longer to load? What is happening? What if I copy and paste it? Okay, and it's a blank page. It's a blank page. It says trending questions, dip circle 15050. What the heck, man? You serious? Oh yeah, I don't know what it is. Continue, but I think we might be able to figure it out. Okay. So magnetic field is at an angle of 66 to its surface in Perth. This is 66 degrees. Do that. This is called the angle of dip. This is information to calculate the overall strength of the Earth's magnetic field in Perth. Okay, but we know it's horizontal, which is 2.61 times 10 to the negative 6. And then let's say this is B, E, B, horizontal, B, horizontal, Earth, so B, horizontal, Earth, let's go that. So then this would be cosine of, so BE is going to equal 2.61 times 10 to the negative 6 over cosine of 66 divided by cosine of 66, which gives me 6.42 times 10 negative 6 Tesla. Okay. Starting the night watch. Oh my god. Yikes, okay, there's a lot of reading. This image cannot be produced. Okay, I'm not gonna get the image up unless I knew. Hey, Rembrandt! The night watch was painted in 1642, but there was something odd about the name of the night watch. It was not the name of the original painting. After it was restored, it became obvious it was a daytime scene, but by the end of the 18th century, the painting had accumulated so many layers of varnish and dirt it looked like the scene took place at night. That's very interesting. Hence it was misnamed the Night Watch. This museum in Amsterdam carried out a large research and restorative project with the aid of X-ray fluorescence spectrometry. Expensive paintings can be investigated harmlessly before restoration to ensure sophisticated preservation of valuable art objects. It also allows the paintings to be restored securely in the building so the public can still all enjoy them. Depending on these X-ray beam penetrates at different depths of the painting surface, allows to examine different layers of paint. You can detect corrections made by Rembrandt without having to remove any paint. It is already known today that Rembrandt's lengthened lances, spears, and changed positioning of people, in the picture. Spectrometer analyzes a specific wavelength given by each sample of paint. It produces a printout similar to the one in Figure 2, showing the abundance of each wavelength versus their energies. This way, based on the detection of the fluorescence produced after the samples were bombarded with X-rays, inner electrons are ejected by incoming X-rays, and other electrons in higher energy shells cascade downward in smaller steps, emitting photon-specific wavelengths corresponding to the energy difference between shells. This fluorescent radiation is element-specific, as the energy of each shell N is given by that, where Z is the charge of the nucleus, which is proportional to the number of protons in the nucleus. Okay, transitions. Oh, I think we've had something similar to this before. There's two properties of X-rays to make them suitable, so we can maybe say high penetration of penetrative power, and then enough energy to ionize, no, not ionize, to cause emissions. Cause ejection of electrons and photon emission and subsequent photon emission. Okay. Explain how we know regards lasted at different lengths and some of the people were in different positions. We are able to X-ray beams can penetrate to different depths of the painting surface. X-ray beams can penetrate into different specific layers of the painting surface. Painting surface. Thus, we can analyze the paintings underneath the surface, the visible surface one. Compare the lower levels, and it would be, which would be earlier versions. Versions of the painting. To the corrected one, to the ones corrected which we see. You have two advantages of using X-ray spectrometry to analyze old paintings. One of them was that you can, the painting itself is not harmed before restoration, so it can be investigated. So paintings can be investigated harmlessly. And two, it is allows paintings to be restored securely in the buildings. This is a sophisticated preservation. And then I say maybe allows for sophisticated preservation. Explain why the fluorescent radiation is element specific. As En is proportional to fluorescent is given by the difference between two energy shells. Energy shells. So fluorescent radiation is given by the difference between energy shells. These energy levels are proportional to the number of protons or charge of nucleus / charge of nucleus. I'll put in brackets charge of nucleus. And I'll just do here. Is n is proportional to z squared over n squared. Each element has a unique number of protons. Hence, we'll have unique En, thus fluorescent radiation, the difference between each En, unique fluorescent radiation as differences will also be unique. Will be unique. Estimate the values of M and L relative to the K shell for iron displayed in figure 2. Place them in the corresponding spaces below. Oh, okay. So it needs to be Z. What number is iron? Do I have a periodic table? I don't have a periodic table on this. Okay, let me see. I think iron is about 25 in the periodic table. Does it tell me? Fe displayed in figure 2. Place them in the corresponding. Wait, figure 2, never mind, it's here. Okay, so what am I looking for? M and L shell. M and L shells relative to the K shell. So if that's the lowest, then L to M. So L is Ka. FeKa is here. So what is that like? So if that's 7, that's 6.4 maybe? And then Kb would be like what, 7.1? Okay, 6.4. And then M is the bigger one, right? Because M is going 2, yeah, okay. So then M is probably 7.1. Estimate the wavelength of the photon given off when an electron falls from the M to the L shell in an iron atom. So then let's see, delta E is equal to 7.1 minus 6.4. So that's 0.7 electron volts, which is equal to 0.71.6 times 10 to the negative 19. 1.12 times 10 to the negative 19 joules. So then E equals Hc over lambda. Lambda is going to equal times 10 to the negative 34 times 3 minus 10 to the 8 all over 1.12 times 10 to the negative 19, which is going to equal and so times 3 times 10 to the 8 1.78 times 10 to the negative 1, 2, 3, 4, 5, 6. So 1.78 times 10 to the negative 6. To which part of the electromagnetic spectrum does this wavelength belong? So 10 to the negative 6. Small, so infrared radiation. How would the graph figure 2 the change of the operator in the spectrometer increase the power of the X-ray beam while keeping the wavelength constant? Explain your answer. Be the same, wouldn't it? Relative abundance of energies of emitted. Wait, that's killer electron volts. I just realized that it says KeV. Whoops. Okay. What's KeV? Okay. That's massive then. For iron. What the heck? This is actually 700. 700 electron volts? Are we sure? Yeah, it says KeV. Oh, okay. It's gonna be massive. Everything would just change by a factor of like 1,000, I think. 16, so 16 here. And this will just be negative 3. Yeah, 16. Oh wait, sorry, no. 9 meters. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1.77. Negative 9. And negative 9, that's going to be X-rays. I think. Emitted photon. Okay. This train offers increased power, keeping the wavelength constant. So there'll be no change. Graph in here would not change. Emitted photons. Relative abundance. Lambda is, so if lambda constant, so is frequency, thus incident electrons or photons still have same energy per photon. So then, as power increases, intensity increases, relative abundance will remain the same. And the delta E's was determined by difference in energy levels, not by difference in energy levels, not by the incident photon energy. Even if you change the wavelength, that means your frequency would have to increase. That wouldn't change anything, would it? So it's proportional. Drift velocity. When you turn on a light, it comes on as soon as the circuit is complete. The energy flowing in the circuit is transferred almost instantly, but how fast do the charged particles which carry that energy move? It turns out that they move extremely slowly. The velocity is called drift velocity and depends on several factors. Okay, so it depends on my current, the electron density, the area of the cross section, drift velocity, and Q is a charge of an electron. Calculate. Copper. Okay, so then VD is going to equal I, which is 3, all over N, which is 8.5 times 10 to the 28 times A, which is 1 millimeter in meters squared. So 1 times 10 to the negative 3 all squared, and then times Q, charge of an electron measured in coulombs. It's just 1.6, right? Yeah. Negative 19. This is all equal to. Calculator's broken, man. Okay, 3 times power negative 3 squared, 1.6, 10 to the negative 19. So drift velocity is 2.21 times 10 to the negative 4 meters per second. This is what's called the Hall effect. It occurs when current flows through a flat piece of metal placed in an external magnetic field. Okay, image. Okay, I'm gonna get this image up. This is 21.
Of course it doesn't exist. Why would it exist? Yep. Access denied. That's not very nice. Okay, hopefully I don't read it. The negatively charged particle experiences a force due to the magnetic field and move to one side of the middle strip. A potential difference in the electric field dividing two sides of the strip measured by a voltmeter, dividing by the width of the strip gives the strength of the electric field. Yep. If the strip is moved at the same velocity as the charge carriers but in the opposite direction, the relative velocity in the field is now 0 and therefore there is no force placed upon them by the magnetic field. Root 0 by measuring how fast we can calculate drift velocity. Magnetic force on the charged particles is that
When the strip is not moving and the system reaches equilibrium, VH remains constant, and the force exerted on the charge by the magnetic field equals to the force by substitution. It can be shown at that. Okay. Explain why VH is 0 when the strip is moved in the opposite direction. The correct speed. If the strip is moved at the same velocity but the opposite direction, the same speed but opposite direction, then speed of the relative velocity of charge carriers in field equals 0 meters per second. Thus, there is no force experienced measuring thus there is no net movement of charge carriers to either side of the strip thus there is no what do you call it, of potential difference, no accumulation of charge, hence no potential difference. Thus, VH equals 0. So increasing the magnitude of the magnetic field will increase VH for a stationary strip when equilibrium is restored. Magnitude of the magnetic field increasing the magnitude of the magnetic field will increase VH for a stationary strip. Increasing magnitude, increasing magnetic field will cause magnetic force on charge carriers to increase. D is the drift velocity of charge. Electric force is equal to QE hence in equilibrium. Force of electric must increase, and F of E is equal to Q V over B, no, F over D. Q and D are constant, therefore V must increase. Or they say it as W. Well, say FE equals F of B. Okay. The article as such derive this equation from the information supplied in the article, where then FE equals F of B. Or magnetic force, they say F of M. F of M, so then we know that QVD derive this equation from the information supplied in the article. Can be shown that derive this equation forcing that the charge carried F of M is equal to the force, so F of M is equal to F of E. QE equals that. I don't think I'm cooking that is. Am I stupid? Why do I not see where this comes from? I see that this is equal to that, we just times it by the charge. Electric force is VQVD from information supplied in the article. I don't think you can do it from information from the article, can you? Maybe this I just put as F over Q. Maybe? Let me do that. So E equals F over Q is V over D. So then F over Q is VD. So then F is equal to QVH over W. Something like that. VH over W. And then electric. Calculate VH if the dimensions are that and that. Copper strip. Use electrons as a charge for copper, that's a D. That's diameter, I assume. And there's a W. Oh wait, no, it's a strip. So if that's W, where's W? Width of the strip. And then D. What the heck is D? Why do I need D? Calculate VH. So VD equals VD equals I over N A Q. So then force of magnetic is Q. It's just going to be I B over NA. Right, so if I sub in VD with that, I NAQ gets cancelled out. And then FM so then FE equals F over M. So then VHQ all over W equals I, B, and A. So then VH has to equal WIB over Q and A. What A is the cross-sectional area. Cross-section of the conductor. I assume the cross section is just going to be these two multiply, but I don't know what's D. What is D? They never mentioned a D, I think. So there's literally no D. I don't know what that is. It's depth. Let's just do this is equal to 3 centimeters of 3 times 10 to the negative 2 times I, which is going to be 26 times 3.5 Tesla over 1.6 times 10 to the negative 19 times 8.5 times 10 to the 28 times area. What's the area? Cross-sectional area. Copper strip, copper strip, copper strip. Oh, I bet D is shown here, isn't it? Oh my god. Wait, not found. Okay, wait, hold on. I was looking at the wrong thingamabobby. Let's see, is this the correct link? What? Oh, it's not even working, man. Come on, work for me. I need this. I need this. I don't know what D is. I don't know what D is. I'm gonna assume it's that. So 0.03. And then 0.001. Here's my calculator. Zero point zero three, 0.001. Well, yep. That seems very, very small. Oh, because these be centimeters. Yeah. Oh no. No, that's fine. I'm just going to use it. 6.69 times 10 to negative 6 volts. I'm not sure if that's correct. I feel like I'm not using D correctly. If I didn't use D correctly, I might not include this question. Or I might include the marks that I would get normally, like maybe rearranging if I did that correct. Yeah. QVDB I. And A is B. Okay, I'm gonna end it there. I'll start marking. Okay, welcome back, guys. Just finished marking. We got 90.9%. I've had to change the total marks for section 1 because there were some questions we couldn't do because the diagrams on the websites didn't match what was like what you possibly could do with them for the marking key. So I took those marks out. But yeah, so we lost 6 marks in section 1. We only lost 4 in section 2, which is pretty good. And we lost 6 in comprehension. So the first marks loss, I just took this question out because I think on the diagram they had a length. I mean, obviously here there is no length. And then also the directions, even if I did them, they were already on the diagram. So I took the whole question out. Yeah, leptons only experience a weak nuclear force. They do not, but I thought that's a fine distinction. And then you could have said leptons are fundamental, so they're also fermions, because quarks are fermions. Hadrons are made up of quarks, so they are not fermions. I lost a mark here because I didn't do the distance between A and C. I just found the distance between B and C, so I only got 2 of those marks. I took out 2 marks here from the total, so I said that was my max marks for this. I lost 1 of them. You got 2 marks on the diagram. However, the diagram on the website, I'm pretty sure it doesn't match it because that diagram is upright, and then the diagram that they were discussing in the marking key had, I think it was tilted, and then someone was applying a torque or something. So I was like, okay, well, I wasn't gonna do that because I didn't have that diagram with me. So I just took those 2 marks out. And here you have to talk about that the person holding down the doll supplies an opposing torque, holding it in static equilibrium. I didn't talk about that, but it is in held on the ground. So I guess maybe I could have thought of that. So I left that mark in there. So I lost another mark there. Oh, this was good. Bada bing, bada boom. And then we lost 4 marks here. I should have said what I said in question A for question B, but it is what it is. So the origin of CMBB, essentially, the Big Bang Theory states that since everything was in singularity, it's super condensed, there was a lot of, it was super, the temperature was to be super duper high. And as we know, black bodies, when they release the energy corresponding to the temperature, so if the universe was very hot, then the universe must have been emitting a lot of black body radiation. And then provides evidence used in expanding, since the wavelength energy of the emitted black body radiation is also proportional to the temperature of the black body. As the universe was super duper hot, that means that its emitted radiation must have been super energetic, so super short wavelength, so like gamma rays, X-rays, that sort of stuff. However, as the universe expanded, so did the wavelengths of the radiation. So then obviously the gamma rays, they started from the short wavelength, they started expanding until they became the wavelength of microwaves, which is what we see in the universe today. I was contemplating, because I did say initially releases gamma rays for the releasing lots of black body radiation. I was like, not sure. I didn't say radiation. I didn't say black body. So it's like, okay, whatever. Okay, moving on. Here, this is so embarrassing. Y-intercept. This is -2. This is -1.5. So, yeah, I got a mark for 2 sig figs though. I'm gonna get myself follow through marks here. I also lost a mark here because I can't believe I was talking about how the photocurrent here should be lower, but then for some reason my brain didn't connect that my photocurrent here should also be lower. So yeah, so the maximum photocurrent must be lower, because like I said, I think I said this while I was recording and doing the exam, the electrons flowing through, there's less of them, so obviously the current has to be lower. So we lost a mark there. But then you got 2 marks for one starting at A and then the other one lower at B. Okay, tension, all of this stuff was pretty good. Boom, boom, boom. We lost a mark here for my line of best fit. I know it's wrong because the gradient we got is outside of the range, but it should have been something more like this, I think. A bit steeper. Something a little steeper like that. Maybe not there, maybe something like this. But yeah, anyway, the line of best fit just had to be steeper, yeah. Something like that. Because the gradient, it was like 1.52 to 1.53 or something. So it was like, the gradient should have been 1.5. 1.3, but I gave myself follow through marks. The phenomenon is called dispersion, which I was rambling on about white light consisting of multiple constituent colors or lambdas of light. But obviously the key word is dispersion. It was literally one word refraction, 1 mark, one word dispersion, 1 mark. So I didn't say dispersion, so I knocked the mark off. Here was fine. Percentage decreases. Percentage error was also pretty good. I think from here it was smooth sailing. Here they used more like words, pretty much. Altitude. It says that the upwards is the upwards thrust counteracts the weight force or whatever. But yeah, if I said the sum of the vertical forces is 0, then all of that is 0, then I gave myself full marks there. I said what they said, just with like variables instead of words, pretty much. And then here, 4 marks, 2 marks, bada bing, bada boom. Good thing I went through and checked that this wasn't, you don't add plus MC squared. That was a silly mistake, very silly mistake. Going down. Boom, 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 boom. Yeah, all of that was fine as well. So then here, I think the first one we did pretty well. Yeah, this first comprehension task we did pretty good when you lost 2 marks. Estimate, so we lost a mark for sig figs there. You only have to go to 2. Explanation. You could have also said it increases, but then like the amount of photons or whatever released it increases. But for me, I thought that it was 2. You could have said increases or no change. I said no change because that makes no sense to me. So I said as power increases, intensity increases, but they talked about power of photons per second increasing, which I didn't, so I took the mark off. And then they did said the relative abundance remained the same. I said because they're proportional, and then if they all increase, whatever. But they also they wanted to talk about they wanted to see that all have increased. But I thought I added this since it's proportional, so I think it's close enough to the mark. Maybe not. So yeah. And going down. These all have increased. But relative abundance remain the same, so it's proportional. Let's see.
I might discuss with some people if I should get the mark or not. Maybe I shouldn't. WACE, no, divided by 91. Plus, I think 37 times 20. 38. That put me at 90.3%. Which is Yeah, okay, I guess I didn't say they all have increased. So I'll put 0. Knock a mark off there. So then this becomes 8. I'll fix that in a second. We would get 90.3%. And then down here we lost I think we lost most of our marks in this section. Yeah, especially our explanations. It's always the explanations, but yeah. They wanted you to say M equals Q, Fm equals QV, QVB, and then when velocity is 0 with respect to the magnetic field, there will be no magnetic force, so then there's no accumulation of charge, and then no potential difference, no accumulation or separation, no potential difference. So I lost those 2 marks, and then here I lost 2 marks again. So then if there's more magnetic force, they wanted you to talk about more separation of charges, increasing the strength of the electric field, and then obviously that increases the voltage that will be experienced. And then go down, but these two, the correct. Apparently, D was you just had to multiply it to get the area. So yeah, I'll fix that mark at the very top. 31, and this be 90.3. Alright, so 90.3%. I'm okay with that. What did we get in the last ones? Yeah, we were getting about low 90s as well. So it's only a percent lower, so I'm not too bummed about that. The 1.5%. But yeah, time to grind out those methods exams. We got 2 more physics to do as well, so hopefully we can bring the physics grade up a little bit. So yeah, hopefully do pretty well this exam. See ya.